Wireless network. Wireless network is an invention of the new era. With the help of wireless technology, we can transfer data from one device to another without using a cable. Of late, wireless technology has gained popularity since more and more people began to use laptops, tablets, and smartphones. Now, these devices have become an unavoidable part of modern life. All these devices can be carried easily from one place to another. Today, we are living in a community where internet has become a way of life. It's no longer treated as a luxury. Rather, it's become a need and a necessity to get an internet connection to the devices like personal computers, laptops, tablets, smartphones, etc. Consequently, this universal need for connectivity has increased the importance of wireless networks. In fact, all of us would have used wireless networks sometime or the other. For example, if a friend of yours asks for a certain music stored in your mobile phone to be given to him, how will you give it to him? You may use infrared or Bluetooth option. Here, we can send files from one device to another quite easily and without using a tangible connection. Moreover, it's practically difficult to use the cables as and when we need to transfer any data. Let's consider another example. The land phones that we have been using earlier were connected with cables, which carried a communication to the telephone exchange. It limits our mobility while on the phone, for it was impossible for us to continue the communication while we leave the house and travel away to another place. However, with the emergence of mobile phones, it has brought a revolutionary change to this situation. Today, we can use mobile phones anywhere at any time. We can continue our communication even when we travel. Remember that you should not be the driver yourself when you use the mobile phone. Hope this example would have explained to you the advantages and scope of wireless network. Radio frequency signals. If the cables are not used, how do we communicate in a wireless environment? In other words, if no cables are used, what is the medium of transmission in a wireless network? Have you ever heard of radio frequency signals? These are also called as RF signals. Radio frequency signals are the medium of transmission in a wireless environment. Before we attempt to learn about wireless networks, it's wise to know the basics about radio frequency signals. The frequency range of radio frequency signals varies from 30 kHz to 300 GHz. RF signals fall under the category of electromagnetic waves. Hope you already know that even the light is an electromagnetic wave. Unlike the light, the radio frequency signals are invisible. These radio frequency signals are widely used to transmit messages from one device to another. You must be familiar with the concept of FM radio. FM radio stations use radio frequency signals to broadcast programs. Very often, the names of the radio stations include the frequency that they use. For instance, 91.9 MHz frequency is used by Radio Mango, whereas 93.5 MHz frequency is used by Red FM. Similarly, television stations also use radio frequency signals to telecast programs. We can use radio frequency signals in setting up wireless networks for computers. Lots of offices and organizations actually use wireless network to connect all the computers in the office to a network. In fact, it requires some special devices instead of the ones that we use in wired networks. In a wireless network, in order to send data, the minimum requirement is the network interface card designed for wireless networks. Unlike the NIC used in the wired networks, NICs in wireless network use antenna instead of RJ45 connector. RF signals are transmitted and received with the help of antenna. Now, you can see on the screen two computers connected with similar NIC. When we connect the computers, the signals from the antenna pass through the air. Since the RF signals travel through the air without any cables, there can be possible signal loss or weakening of signals. Obstacles on the way can stop the flow and strength of RF signals. Just as we've discussed earlier, even light is an electromagnetic wave. You would have seen how obstacles on the way can hinder the passage of light. Though the radio frequency signals cannot be seen, it can still be hindered by obstacles on the way. Metal parts, concrete walls, electronic equipments, and even the human body can stop or weaken the radio frequency signals. Due to any such reasons, if the signal strength decreases, it will eventually cause the overall speed of the network to decrease. Have you ever wondered what are the causes responsible for the decreased speed of wireless internet? When we take wireless internet from an ISP, we very often will not get the speed that was offered by the service provider. In fact, it's the above said obstacles on the way that has caused the decreased speed. Though the speed is less in comparison to the wired networks, wireless networks can be set up very easily. Imagine that you're working in an office where you need to connect all your computers to a network. If you choose wired network, the cables may need to go through the walls. Wired networks take more time and money. Instead, if we set up a wireless network, it saves on time, labor, and money. The communication in a wireless network is possible with the help of radio frequency signals. However, we are not allowed to use the RF signals in any frequency as we like. In order to get the authorization to use a particular frequency of radio frequency signals, it would cost anything from 1,000 crores to 2,000 crores. This investment is done against the exclusive permission to use a particular radio frequency. However, in order to realize the wireless communication, we still need to set up the network using costly wireless devices. If this is the case, to set up wireless connection between two computers in the same room or two different rooms in the same building, what will we do? Obviously, we will not go for wireless network due to the huge investment associated with acquisition of the license. However, there are 3 radio frequency bands that are available for anyone to use without registration. These frequency bands are also known as Industrial, Scientific and Medical bands, ISM bands. ISM bands use the following frequencies: 900 MHz, 2.4 GHz and 5 GHz. These 3 bands were released by the Federal Communication Commission, FCC. As the name indicates, anyone can use these frequency bands for various purposes. In addition to the computer networks, many other devices also use these frequencies. For example, microwave oven, cordless phones, medical equipments, etc. use these bands. That means the presence of any of these devices can create conflicts to affect the performance of our wireless networks. So far, we've been discussing about the basic function of wireless network and the frequency used for it. Now let's proceed to learn about different types of wireless networks. Types of wireless networks. Based on the size, wireless networks are divided into many categories: wireless LAN, wireless MAN, wireless WAN, wireless PAN, etc. In addition to these, there are many other subcategories as well. Wireless LAN. Wireless LAN is a network of 2 or more computers that covers only a limited area. If the LAN is too small, we can depend only on wireless network interface cards to make them work. Such devices, which can communicate without a central device, are also called as peer-to-peer network. These kind of peer-to-peer networks are also called as ad hoc network. By and large, such networks are set up only for temporary purposes. Normally, we would not require a coordinator when we discuss about anything with 1 or 2 people. Imagine there are 10 or 20 people participating in the discussion, and if there is no coordinator, can you imagine what will be the destiny of that discussion? I hope you would have seen coordinators controlling discussions and talk shows on the television. Similarly, if there are only 1 or 2 computers, we can connect them directly as a peer-to-peer network. However, when we increase the number of computers in the network, it would obviously necessitate the role of a coordinator. In case of wired networks, it's the switch that coordinates the communication, whereas in wireless network, the switch has been replaced by a device called access point. All computers in a wireless LAN communicate through the access point. Wireless LAN that are using access points are called as basic service set. Wireless fidelity. There are certain protocols and standards required to be followed by any network. For a wireless LAN to function, it uses the wireless fidelity, popularly known as Wi-Fi technology. In other words, Wi-Fi is the short form of wireless fidelity. While checking the configuration of a mobile phone, we usually check if it's got features like Wi-Fi, 3G or 4G. The interesting fact about the situation is that, though many people ask for these features, very often they don't even know what is meant by these features. Under Wi-Fi technology, wireless LAN transmits data with the help of radio frequency signals. The frequency of RF signals used in Wi-Fi technology can be either 2.4 GHz or 5 GHz. Hope you remember our discussions about ISM band. The range of such a wireless LAN is about 100 meters. Wi-Fi technology is widely used only in wireless LAN. Wi-Fi products are tested and certified by an organization named Wi-Fi Alliance. We can see their trademark in most of the Wi-Fi devices. IEEE standards. There are various standards designed for different types of wireless networks. The Institute of Electrical and Electronics Engineers, IEEE, is the authority which determines and regulates various standards for the functioning of wireless networks. The network standards are mostly designed by 802 Committee, which is a part of the IEEE. For all the wireless network standards made by them, we can see their label IEEE 802. To support wireless LAN, they have designed the standard IEEE 802.11. It was only in 1997 that the first wireless LAN came into existence. The wireless LAN functioned under IEEE 802.11 standard, and it used 2.4 GHz frequency. The maximum data transfer speed achieved by this standard was limited only up to 2 Mbps. This standard is now known as IEEE 802.11 Legacy. There were 2 new standards released in 1999. They are IEEE 802.11a and 11b. These standards, in fact, have come with many improvements from IEEE 802.11 Legacy. 802.11a used 5 GHz frequency, and the maximum data transfer speed is 54 Mbps. Though it's faster than IEEE 802.11 Legacy, not many people preferred to use it. 802.11b, which has been released in the same year, gained more popularity. 802.11b used 2.4 GHz frequency, and the maximum data transfer speed was up to 11 Mbps. Though the speed is lesser than IEEE 802.11a, the 802.11b earned more popularity since it has used 2.4 GHz frequency, the same frequency as the original standard IEEE 802.11 Legacy. The new 802.11g with the original standard frequency of 2.4 GHz has been released in 2003. 11G standard has also offered the data transfer speed of up to 54 Mbps. 11G standard has been accepted widely and is still being used. However, IEEE has continued their research and improvement plan to design better and more efficient wireless network standards. 11N standard, which was released in 2009, offered enhanced speed of up to 300 Mbps. 11N standard is used in most of the new generation wireless networks. It can also function with both 2.4 GHz frequency and 5 GHz frequency. Considering the ongoing effort and research by IEEE, we can expect faster and efficient wireless network standards in the years to come. Wireless security. The safety and privacy that is offered by wired network is similar to a house with all doors locked and windows closed. However, wireless network is similar to a house with all doors and windows open. Compared to the wired network, there is increased risk of data loss transfer and hindrances of communication in wireless network. Moreover, anyone can easily hack the data from the wireless network in the absence of proper security measures. The RF signals traveling through the air can be intercepted by one using an antenna. Hence, there is a high risk of unauthorized access in wireless networks. In order to ensure data security, we need to set up appropriate data security measures. Let's learn about 3 commonly used security systems. Wired Equivalent Privacy (WEP), Wi-Fi Protected Access (WPA), and Wi-Fi Protected Access 2 (WPA2). Wired Equivalent Privacy (WEP). WEP Security Standard was released in 1997, the same year in which Wireless LAN 802.11 Legacy was released. WEP has been made with the realization that wireless LANs are not as safe as wired LAN. However, WEP has failed to serve its purpose since it has used an easily breakable encryption algorithm. Practically, WEP has failed to provide equivalent security to the wired network.